A full wall of running fans can still leave birds in a dead zone. The real question is not how many fans are installed. It is whether the inlets, pressure field, fan bank, and controls deliver the right air where the animals actually live. In minimum ventilation, the inlet is part of the air-moving system. The opening in house static pressure must create a sealing jet with enough throw to mix incoming air before it descends. If cold air drops directly onto animals or litter, the building can have the intended air change rate and still have poor local conditions. Tunnel ventilation is a different mode. Air enters through the pad or tunnel inlet, travels the length of the occupied zone, and exits through the exhaust bank. The design must control the path, limit bypass leakage, and verify velocity from end to end. A high average does not erase a slow pocket around equipment, partitions, or a weak section of the fan bank. Air exchange and animal-level airspeed solve different problems. Moisture, ammonia, carbon dioxide, dust, litter condition, animal heat, and uniformity all matter. Measure pressure, temperature, humidity, and velocity at representative animal height and across the full house. Use species, age, density, and climate-specific guidance rather than one universal number. Fan capacity changes with static pressure. Inlets, shutters, guards, cones, cooling pads, leakage, and dirt all become part of the system resistance. The operating point is where the fan curve intersects the house system curve. Free air airflow is not delivered house airflow. Treat fans, inlets, shutters, and evaporative pads as one system. Minimum, transition, tunnel, and cooling pad modes place different demands on the same components. The weakest or dirtiest component can cap the result. Select a fan at the expected operating pressure. Compare airflow, efficiency, airflow ratio, drive, materials, shutter and cone configuration, corrosion resistance, service access, and independent test data. The product image tells you the architecture, it does not replace the installed duty calculation. Dirty shutters and wet or blocked pads increase pressure loss. As pressure rises, airflow falls and house velocity can fall with it. Keep a hot weather margin, measure pad pressure drop, inspect shutter opening and trend fan current before performance becomes an animal welfare event. Ventilation should stage from animal age or mass, outdoor conditions, house temperature, humidity, air quality, inlet position, and cooling pad state. Each stage must preserve a useful pressure field and inlet pattern, not just add another fan. Loss of grid power or a fan bank is a life safety thermal event. Alarm quickly, start backup power, move inlets to a safe state and verify that the air map recovers. Test the sequence under a credible load instead of assuming a generator label proves the response. Commission the complete air map. Record operating static pressure, inlet jet throw, animal level velocity, end-to-end speed, temperature, humidity, and air quality. Repeat the checks with realistic shutters and pads, not only with a clean empty house. For an engineering review, release one house duty package containing geometry, animal load, climate, ventilation modes, target pressure and speed, inlet and pad data, fan current, controls, backup response, and acceptance tests. That evidence makes the ventilation design reviewable and serviceable.